So welcome everyone. I hope the mic is clear enough to hear me. My name is Jonathan. I'm going to spare you my last name in English. But we're doing some lateral tension, retention, and maybe some of you know me, some of you don't. But we're going to get into lateral tension and professional glue pulling. And we hope to take it to a next level and solve some problems for you guys that are clearly out there, for all the ones that are doing professional glue pulling, big dent repair, using lateral tension these days. And there's a lot of stuff out there, and there is some interesting stuff to learn and to know about it. And strangely enough, I'm going to start talking to you about a tech tip first, about a plant, a flower. So what does a flower to do with our technique? It's, has anybody heard about the Lotus effect ever? No? Yeah, you do? What did you hear?
It's the effect of, it's hard to put in words, but a small object, surface tension pulls everything.
Exactly, he knows. So why is this interesting? Let's get into it. So there's a German scientist that detected or found out that water or other stuff doesn't have a grip on the lotus leaves, and it just runs off. Dirt, water, whatever you put on those leaves, it just runs off. Why is that so interesting to know? Well, they researched those leaves, and they found out that you can see it's highlighted here, really enlarged, and you'll see on the bottom here, debris, water, nothing stays on that surface. So why is that interesting for us? They made clothes and other stuff mimicking this textile or this leaf to make sure it stays clean. But there's something interesting to know for us as technicians while you're prepping that has to do with this Lotus effect. I met last year a German scientist and an engineer developer. His name is Carsten Schubert, and he is a glue developer. And I was explaining him some problems people have with adhesion of glue. And as you know, what do some people do with tabs? In their head, they think it will have a better adhesion. What do?
Scratch it up.
They scratch it and they scuff it up. Yeah. But strangely enough, all of us coming out of collision in the past and that have done painting, you know you should sand stuff to get a good adhesion. No? Because if you paint on clear, you can just, it comes off. The power washer and it just comes off. But we discovered that with glue pulling, it is exactly the opposite and has to do with the Lotus effect. What is now happening when we are scuffing or sanding or actually roughing up the surface? So before polishing or when we sand it, you have scratches. As you can see here, scratches. This is sanded, and here is someone sanding a tab. Now, in the way of thinking of collision, it might sound logical to do that to get a better adhesion, but this is what happens greatly enlarged with your tab. And the tab, this is the surface 1,000 times enlarged, this too. And what happens is all the scratches that you make in that tab, they go deeper into the tab. And what happens with glue? It's a simple sketch, of course. But when you rough up the surface of the tab, or anything that you want to glue on, is the scratches will create a Lotus effect, and the hot glue, or the way the glue is composed, is too thick to glue into those scratches, and it'll stay up. What happens? All the air around, the air is thin enough to get in between, so the air will get into in between your tabs and your glue. So the thing that you're trying to do, get a better adhesion, is working against you. So what do we learn from this? The better, or the more polished your tabs are, and the paint, the better adhesion with hot glue. Because hot glue needs a flat surface, as flat and as shiny as possible to get a good adhesion. So stay away from the scratching or the scuffing or the sanding. The same thing if you guys doing big dents and the paint came off and you need to create a surface to glue on, well, you should get that surface, even if it's bare metal, you need to almost polish that metal to get the best adhesion. Exactly again, Lotus effect, because your glue will not sink in to the scratches on the car. Important tech tip to know. Lateral tension, retention. I think a lot of you came to see and talk about this. Why is it this retention system different than just pulling on a strap? The system here does lateral tension. You can bend it out of the way left to right. It has lock-on lifters and actually creates a lateral tension between 2 points, and at the same time you can lift. So there's a triangle of tension that you are creating to make sure that dent will relieve or let go of its damage that was created into it. Why is it so logical on big dents to use lateral tension or a type of lateral tension? Well, if you see how panels are created, the constructors have pushed in their molds a lateral tension over all the side parts of the car. So the fenders, the doors, quarter panels, all of them have a lateral tension outwards pushed into them. So if the dent went over that lateral tension and created a dent, the most logical way to bring that back up is to just apply lateral tension again and come as close as possible to what the constructor or the car manufacturer has put in that car. Reshaping it that way is you have to study, like this is a photo of Martin, Martin Sadler is here. I used some of his photos. Thank you, Martin, for letting me. As you can see in a lot of the photos that we will show you, the lateral tension is created over the panel, as close as possible to the edges. And we're going to explain you why that is so necessary. A simple way of putting it is, you don't want to be mangling inside of the door here if you can put an overall lateral tension on that same panel. And why is that? If the panel is, of course, a panel without reinforcement, without braces in there, it's still okay. But the moment the panel is glued on the inside with braces and other glues, and you start doing lateral tension within a door, within the boundaries of the edges, you have more danger of creating or mangling up the metal at that place. Allowing you from edge to pull, that is a challenge we always have, the guys doing big dents. How do I pull as hard enough on the edge and being as outside as possible on that part that I want to create? So that's a challenge for the guys making the feet for those systems. Feet, straps, whatever you're using, you want to make sure you can create an overall tension on the dent that you are repairing, making sure that when the braces are in there and everything wants to release back to original, if you release your system, then you got an original door, part, or quarter panel to work with. So this is another one of Martin's, and this is exactly what I was saying. It was a big repair that he recently did. So let's see, I think this is normally a video that I can play. No, it's too fast. So he does exactly what we want him to do, or what he wants to do himself, of course. I don't know if you have a video. So why did I take this example? There is a lot of pressure being applied here to bring that door back to original, and a lot of pressure is necessary. If you see the tool on the bottom here, then you see it's almost bending with the pressure he's creating. So why is it necessary to do this? If you use lateral tension and you are using it, you know you can bend the tool out of the way. We have the lock-on lifter. But you saw what he did. He just used his hand. You can use hammers. And a very good way that we recommend is to use cold glue first to try to release that tension while you're using lateral tension. Why is cold glue such a good way of using or taking dents out? There is a very specific reason why. If you are using lateral tension And you want to create metal flow. What is metal flow? A dent releases, and it releases back, and hopefully releases all the crowns and comes back to original. Hopefully. That's the goal. So you need to choose where you want to run through that lateral tension. What he did is the lateral tension is he's releasing here, he's going from here to here. That is where the lateral tension runs. So you need to decide, do I want up here? Do I want to be here, there, on the bottom? Your lateral tension line is here. So you want to be at the strongest part to pull back lateral tension. If there is a character line or a body line running through a door, lower or whatever, and there is an impact on it, you want to bring the strongest part back to where it needs to be. And first, use cold glue. What is the big difference between glue pulling and cold glue? If you use glue pulling and you have a tab that you glue on, you lock in the dent at the spot where you are gluing that tab. That tab, even with the flexible glue, is locking in that place of the dent. So you pull, but you almost have to rip that tab off, and we know how good they stick these days. You will create a spot there that you will have to fix. So if the lateral tension is enough to release with cold glue to bring the panel up where you want it to be, to just fix the details, the cold glue is always better because it's a flexible material. You push on it and you release it, and that flexible material is going to move with the metal. And if there is metal flow, the whole thing is going to release. And that cold glue is not going to interfere with that metal flow. If it's this shape that you want to release and you glue the tab in there, you are blocking metal flow. You only want to do the lifters as a second step, because in a lot of occasions the cold glue is not going to release it. Then you use the glue pull, of course. But first, lateral tension with cold glue. You want to allow your metal to flow. And I see some guys sometimes just glue up the whole thing, and then they say, I have no metal flow, I don't know how to create the metal flow. You know what? Guess what? You block the whole thing. The metal can't move anymore because you're holding it with all the glue tabs that you put on there. So, important tip. Constant tension in lateral tension. You see here, before you put the extrusions into the tool, we have new ones coming 2 meters long because of the Germans. They are repairing all these big Mercedes vans on the sides, and the 120 centimeters is not long enough for them. So you can just get extra extrusions and make the tool longer. But in every lateral tension system we have, even the small one now coming out, we have these springs here. And the spring idea is something Mike O'Grady came with his tension puller with the spring in there. What happens is, you push in the spring, and when the spring is pushed in completely, there's 120 pounds of pressure there. What does that pressure allow you to do? Every hit you do on that metal, or every pull, cold glue pull that you do, there is a tension pushing on your metal. Even, very interesting, on every swing of the knockdown or a hammer, that tension is pushing it out. So every time you make a move, something happens in your paddle. And that is what those springs are doing. So, important to know, you won't see them when the extrusions are in there, but you push the tool and when you got it up to tension, there is already 120 pounds of pressure from those springs pushing the whole time. The lifter, the same thing. There is the same thing in there. Why would you need it? It's clear for the lateral tension, but blending and cleaning up your panel. I see sometimes guys sending me videos, and we get videos from everywhere, and thank you for that, because we love all those different repairs that we see from around the world. Very nice to see people enjoying the tools. But in a lot of occasions, guys do the first release and then just take the tool off. Profit from the tool until the end of the repair almost. Because when you're blending, the lateral tension is still helping you. If you put lateral tension on the repair and you blend with the hammer, that dent, that high spot that is not originally pushed into, I'm talking about metal, not aluminum, metal, it wants to release to the original molded, pressed part that it was when it came out of the factory. So even for blending, it will help you stabilize the panel. Because we know sometimes bigger panels, they become, you can have risk for oil cans, but put some tension on it, even for pushing, less risk in oil can. Better blending. So you'll try it, you'll see how it works. But I said this about the lateral tension here. We have an example. If a cross-through section of the door, what happens all the time is, what people forget is you have the box of the door of the chassis here. But if you look at cars in collision, for sure the collision section here, if you see an impact in a door and the impact is big enough, still repairable, but big enough, what happens if you see the door and the quarter panel? The gap opens up and you can put your hand in between sometimes. So what does that tell you? The chassis of the door or the box came in, a few millimeters, but it came in. So you want to make sure, if you repair, if you start pushing that and you have that problem of the gap, you will create oil canning almost 100% sure. Because you want the box of the door, you want the box back at its original position. So if you bring the box of the door with lateral tension as far out as you can, and then release all the pressure, you'll have a way quicker and better repair. And this is exactly what we're saying here. This is a door of a Mercedes, and could repair it in a half an hour to make sure that we apply this. Again, this year, let the center line between the feet always run through the strongest part of the damage you want to repair. Going back to this here, I think it's clear for most of us what the strongest part in this dent is. We want to make sure that we have the feet here on the body line, there on the body line, that we can recreate that body line, releasing all the pressure in there. And pushing or pulling only is not going to fix this dent. A combined repair with lateral tension is. So the prepping, we've been talking about prepping also since my Kiko time with 6C prepping and you name it. The prepping is as important as it is to start painting. No painter will take a car from outside, put it inside and start spraying paint on it. You need to respect the prepping steps. Same for us here. And if you think again on the Lotus effect, that is why, guys, if you polished paint and you took a few microns off and the paint is more mirror-like, that's why there is such a good adhesion. Because it's as flat as possible, you have a flat tab, and then you mimic that and put glue in between and start pulling. A tip there is, you always want to pull with tabs that mimic the strength of the metal. Sometimes it happens, maybe when you do hail, you notice this pretty clear. You have a dent here, you glue pull it, the tab performs great. It just pulls the dent out and gives you a high spot, repair it, knock it down, done. Next to it, almost the same dent, you pull, it pops off, nothing happened. And when you look underneath, there's a brace there. So the metal doubled. And all of a sudden, that tab, repairing the same dent, is not capable anymore of fixing that dent. So there are two solutions here. Or you cut some of the glue, and you make sure that that panel is one panel again, not a double, and the tab starts performing again. Or, if you have no access, you have to double its strength with the tab to get it up anyway. So, tabs and strength of metal need to mimic, and if the tab is almost as strong as the metal that you are pulling, there will be a good move and a good performance. But if it doesn't move, and the bigger you go, the more important this is to apply the right pressure, the glue, the prepping, etc. It's coming to the next point here, glue gun. You see the glue sticking out here? I heard some big dent repair guys complaining to me the last 2 years, my gosh, why are these feet so big? Yeah, the reason is, the bigger the real estate of the feet, the less risk of creating damage. Smaller the feet, this tool, we tested it over 1,200 pounds of pressure, and it didn't budge, it didn't move, nothing happened. But of course, 1,200 pounds of pressure connected to a body panel has a big risk of mangling up the panel. So, the ball feet here help you out. You see I jumped on the door here just to repair this, but the ball feet also allow you to move with the metal. Straps also move with the metal. You want to have a tool, if you're doing lateral tension, your first pull on a big dent, and the metal is really moving in angles, you want to make sure that your tool is capable of moving with those angles. Because if you have a tool that is blocked, and you apply a lot of pressure, you will mangle up the edges while it's glued. So the tool needs to move with the metal. Again, metal flow is like water, eh? Water is running. If you block off the water, it's running in a different direction. If you block the natural flow of your dent, it's going somewhere else, because you're applying a lot of pressure. It's a logical way of assessing that. This is the straps that come with the tool as well. The edge feet, the normal foot, you can just put those straps on and apply a lot of pressure and pull like you would with straps, same kind of feet. They don't only adapt to the system, but also allow you to pull on edges like on this van here. It's a 2 meter side without how many feet is that, 2 meters?
6 feet.
6 feet, yeah. No doors in there, so there's no tool right now that can cross the whole section, so you have to use something else to get there. These are the different feet here. Big foot, the smaller one, the mini retention foot here is exactly half the size and a different kind of shape than this foot, the edge here, and then we got the double hinged body we call them, that will bend over any body line that you want to pull on. Of course, most logical thing again, this big foot here, if you glue it on, no risk or little risk of distorting the metal. The smaller you go, the more you have to take care of creating damage. If you use those bodyline buddies, you don't want to just use glue here and here, because then the top will be unstable. It's meant to have glue just everywhere on this tab. Glue it on there and it becomes one piece while you start pulling on those bodyline buddies. And they have a double hinge to make sure you can just grab about anything and then apply lateral tension on what you want to do. On fenders also, just follow the lines, apply pressure. It's a double tool, so it pushes like concave round dents, Porsches, minis. We were talking about the mini repair yesterday. Sometimes you need to push pressure together to allow a round fender to come up again. Lateral tension makes no sense. Pushing is the most sensible thing, because you want to push and allow a lot of metal to come up. Push and pull with the lock-on lifter. So just some tips to make sure that you apply these bodyline buddies, because I had some guys using it and they did not glue the center. As you can see here, it's on a Tesla. This was a training in France. We pulled out a dent there, and this is how you can apply them, but I think it's a logical way of putting them on there. So if I ask you guys now, the big repair guys, what is your biggest problem you have today?
So my biggest problem is I have 3 different systems, and sometimes I don't know exactly when to use what. I mean, it's easy when I have my dent rods or whatever I'm using, I can just pull and go. So I know I need to get a bodyline buddy though, because I don't have that. But just trying to understand what, I don't want to keep working against myself, and I'm finding myself doing that.
Yeah.
So that's my biggest problem.
Yeah. Well, assessing the dent, it is really easy to assess this type of dent.
Yeah.
But if you're assessing a big dent, collision guys have a little bit easier there because they've been repairing big stuff their whole life. They know the limits. They've been cutting off, welding on, cutting roofs off, you name it. I've been in collision since my 16 years, since I was 16 years old. So doing a big thing doesn't scare you guys because you know the limits of the metal. You know what happens and you know what makes sense and what doesn't. So assessing it is really important. And for sure, assess it on the inside. If you start and then just don't look at it on the outside. If it's big enough, take your time to R&I it. Take the bumper off. Look on the inside. Where are the braces? What kind of substrate am I working on? Is it aluminum? Is it HSS steel? Is it steel? We're talking in those three different things. The aluminum, HSS, and the normal steel. We're talking about 300 different materials that you can encounter in your repairs. So the bigger it is, please take some time to assess what you're doing and then decide where you will start this repair. It's a step-by-step process. Big dent guys, they can write you down what the approach is and they can predict how the metal will react by assessing what you are repairing. Another problem I heard all year long is, man, these big feet, the glue. I can't get the glue on my pads. I need reflashes, I need this, I need that. So do you agree, the glue problem? I think it's not the glue, I think it's the gun.
Yeah.
So again, shot from Martin here. And I couldn't explain it better than what he's doing here.
Fill in the full surface and not leaving any gaps.
So you saw what he was doing, huh? He used two guns and still I wasn't really happy with the result to fill up that tap. So what is the solution? Maybe some of you saw this. I had the teaser out. Let's look at same gun, same push. Again, even more professional. Look at the size of the box to show you how big it is. So I need to stop because no more room. Look at the size of this box. Completely filled it with glue, with one gun.
I was about to say.
The thing is, open this
That's
gun.
from space, man.
We got a solution with that too. You can pour in or add in every tab or glue stick that you would want to add in there. And the advantage of these type of glue guns is the whole container is melted. So if you can see in here, all the glue that is melted in there is ready to use. This one has the same system, but is even more interesting. This one has an air nozzle on it as well. So there is air pressure on this one. The moment you push, you just release. Same thing. We have the container here now filled up with glue. Close the container, and as you can see here, you just push and you start pouring out the glue as much as the container allows you or is filled up. As you could see earlier in the movie, I just with the rest of the container on this now, but I filled up the complete bottom of this box with this air gun. So this is the most professional approach you can have. Very interesting on this one too is the glue gun is actually a heater, and you can put these containers like silicone cartridges in there and you can change them. If you have another preferable glue that you don't want to contaminate with any other glues, then you just take another container, you fill it up with your preferred glue, you put a nozzle on it, and you can just add it in there, heat up the whole container, and you're ready to go. If you can see, this is unbelievable to use. This is a real professional glue application approach. This one here that I showed you earlier, this is the basic model. Most people prefer this one. As you can see, you can just pour out a lot of glue with just a squeeze of the hand, and it's done deal with just having no glue available or not enough glue coming out to fill up those tabs. As you can see, the glue that is actually in the gun and melted is ready to use. There's also a really interesting extra for these type of glue guns. You can actually add 34mm glue sticks. You can add the glue sticks you like to use, like the Camel collision or the Pico collision. You can do the tag glue in there, and you can add just sticks in there. If you open them up, so you cut those sticks in half, and you can just add them into the gun, melt them, and your preferred glue is ready to use, and as much as you want to use. But the really big thing that is coming, at last, because of these professional goods, there is something really interesting. We can start using really professional pellet glues. And how does that work? Well, you just take your gun, you grab your glue, and you just fill up the container, melt it, and make sure you close the container, put the gun straight, wait a little bit for it to melt, and your professional glue application is ready to use. So, very interesting stuff coming. So,
That's very cool.
How long will it take those pellets to get hot after you pour it in the gun?
5 minutes. 5 minutes. And the next question will be how heavy is that gun? We'll pass it on because I brought one.
How cheap is this?
Well, this one, the basic model, is going to be around 700. Yeah. And talk to me, Bryce, after this meeting. Because I brought two. But I want you to not only see it, I want you to feel it. Pass it on and just pass it through. And guys, we are not talking about hail, we're talking about big dent repair here. There is no time to play with batteries. The wattages of those battery guns is child's play or hail play. That's good for that because you don't need more heat to fill up a small tab. But everybody doing big things experience the gun stopping. Maybe you damaged, broke some. Pass it on. Pass it on.
Out of curiosity, every time you squeeze the handle, is that air going into the container?
This is not the air one, this is the mechanical one. So what happens is the whole container melts, and then on the bottom, it accepts the glue and it just squeezes out everything that's melted in there. So I think about 5 to 6 sticks worth of glue.
So it just works off of like gravity then on the inside of here?
Yeah. You keep the gun up. You don't want to lay it down because there is air here, an air opening, and you want the air to get in while the glue is running out. So don't put the gun this side or upside down because your glue, you close the gap and then vacuum comes in and then bubbles and you name it. Just
Understood.
yeah.
Do you reuse glue?
I don't.
You don't?
And I don't sell glue yet, so I can still say, don't do it. And I'll tell you why.
It's actually way
We all know the putty. How long is that ago? The little pot. How long is that ago? Dentblue.com or so. What was the guy's name? Blue Pot. That's it. 2012, 13. I was here at the show then, and he had it there. The thing is, I was this year working with engineers on glue, and he said to me, you can't ever do that, and tell you why. Every time you reheat the glue, it changes. Because the diluents in there, like isopropyl and other stuff that's being used to get the glue up to a usable glue, they just fly out. The fumes you see coming out of the glue is not just hot glue. The fumes are all the diluents or the thinners or whatever going out of it. So some glues might seem reusable but don't have the same strength, but other glues become so sticky you can't even get them off the panel anymore in a proper way. So reheating glue, it might be tempting if you buy expensive glues, But there is a second reason why not to do it. The glue is always contaminated with dust and dirt. And if you have an expensive gun, you'll be running the dirt through your gun. And you'll be cutting the lifespan of your gun by doing that. So when the gun passes on, we're going to go to another thing we did or tried to do, and it's only halfway yet. That is, we developed also tension tabs. What are tension tabs? We have them here. These are the collision tabs that come with the new kit that we bring out here. We actually developed, we also patented it, a tension head. So what happens, I'll play a little video here, and then you can see it in the video. As you can see here, on top, there's two tension lips that squeeze. So you just grab the tab from behind, you slide over, you pull it off, and the tab cannot fall out of the adapter. This is the bigger adapter, as you can see, still stays in there. These tabs, they squeeze into the adapter, and the tension of those lips pushes against the wall, so you pull off your tab, and the tab stays in instead of flying around. So we have these three now coming out with the smaller retention system. But pretty soon we're going to have some range of hill tabs ready with the same head on it. That if you use slide hammer or a mini lifter, your tabs won't be flying around, and you can use it with the lifter that you used to work with. So this is the new version of the pull lock. Just to show you, you just have the tab glued, squeeze it in, you pull it off, and then you can see you can start as wiggling as hard as you want, as long as it is in there. Pull the tab out, and the tension tabs keep it nice into the adapter. So as you can see, the pass-through adapter from Kiko, then all the other adapters from all the manufacturers lifted with the same opening, and then this opening in this slide hammer, the new version of the Bulldog, and it just doesn't fall out. Will make your life easier as a technician. So, yeah.
And I just want to ask before we get too far, what temperature do you set the?
It's going to be with an adaptable temperature gauge from 170 degrees Celsius to 190, but it is the exact collision temperature you would want for like Camelot collision glues or the Anson collision glue or those. You can choose the temperature up and down in between that range that you need for the glue.
Regarding the tension tabs, outside of the convenience of them not flying everywhere, are you noticing any actual function on the pull difference as well?
Well, they grab like any other tab underneath the tab, so I don't think it interferes, didn't see any interference so far. It's just keeping it in, like every time you pull off, you pull with a lifter, it doesn't fly on the ground. Or who is not picking up tabs every day while you're glue pulling?
Yeah.
So I'm not saying they're not going to fly out ever, and you don't want to keep them tensioned if you're not using them, because you want those lips to have tension afterwards. But they are staying, as far as I tested them, I worked with them, they're staying in. And these are of course collision tabs, they're bigger, they're not for hail, to use with the retention system, but there are some hail tabs with the same principle coming out, and we'll see if you guys like them or not, but it's, yeah. And Barry really liked orange to stick out and to make sure you can find them if they drop on the floor in your car anyway, or whatever you have them, then you see, oh, I forgot my tabs here, I need to pick them up and pass them on.
Out of curiosity, when you talk about the hail tabs that you guys are coming out with, like obviously when we're pulling on the stabs, the heads snap off or they break down the bottom. With these retentions that you have with the springs on the side, I guess the pressure point when you go to pull is even smaller on that head.
The tension lips on the side make sure the tab is exactly the center when you start pulling. So no tweaking of that slide hammer or no wrong placement in the lifter, because the tab pushes itself straight in the adapter.
Gotcha.
And of course, we know a lot of guys try to invent adapters to grab tabs and to make, but it always make lifters bigger, heavier. So having this on the tab now, I'm curious to see what,
I see what you're saying, like
Yeah.
even how this is designed. I was thinking that the lips. maybe
we also listen to you guys. I need to speed up a little bit because I'm gonna get out of time otherwise. We made a mini version of the retention system. It grabs the same extrusions, so it's interchangeable with the bigger system. We also have now extrusions 2 meter that you can connect. They're gonna be online pretty soon. But this one has also a push spring in it, but we made it lighter, and a lot of PDR guys requested to have a lighter version of this tool. So like you see here, it's gonna come with 2 traction tabs and those 3 tension tabs in there, the lockout lifter. It's a bit shorter also because this one is a lower tool, but it has the same features. Bend out of the way, you can put the lockout lifter there, and it's a bit lighter. But on the weight, sometimes I hear guys say, but the weight, all these lateral tension tools, the weight. I don't really agree, because if you glue the feet on and you put the tool on there, and it'll put a little bit of tension, you can just do whatever you want with that tool. Did you hold up a hydraulic puller in straps and made it ready to start using it? That is heavy. If you want to put 2 on there, it's even more heavy. It's safer to do with 2 guys. So it's actually not really heavy, but we had to go this heavy enough to make sure we could have that 1,200 pound pressure without the tool bending. We did test with lighter extrusions, and the extrusion did this. I bent the extrusions, doing lateral tension, and the feet did not come off, but the tool bent it. So we had to go this strong to make sure the tool held up for all this lateral tension pressure. So this is the difference between the big tool and the smaller one. You see there is quite a big difference. The big tool, of course, if you want to do doors and cross doors and bigger panels, roofs, whatever, is the preferred one to go to. But you have guys that want to use it and always do relative small dents and still want to use a lateral tension tool. That's why we actually created. So also this, I think most of you know the tip I did 10 years ago with Kiko, the 360 JVF tip here. This one is almost half the size. That one is half the size of that one, and that's even smaller. Knockdown or hammer tips. So they're extra tips to use, just repairing dents. Different tips, but we like the square and the angle of that tip, and we went smaller and smaller with it to have a range of knockdown tips, as you can see here. Bryce allowed me to use this picture here. I asked him before. Why is it so nice to see here? Of course, it is good to do hybrid repairs. So please just use whatever you have. We are never saying this is the only tool you need to use. No, it is an adding to your arsenal. But just use whatever you think. Again, in writing the script of the repair of the dent, you have a whole bunch of tools in mind that you're going to use on this repair. And like he does here, lateral tension combined with pushing, well, please do it. Just use whatever you want to use. Look at Eddie Martin here. This is a guy from Holland. Just different setups. You can see here the ball feed and the turning allows you to do that on fenders. Those ball feet, you can put that on roofs, on Porsches, or whatever you want to do lateral tension on. Also, that adapter here allows you to pull. This is a tab from Charles Camoto. So you turn it, there's a hole in there in the lockout lifter. And you just put it over there, you put the rod through, and you're pulling Charles tabs or any collision tab that you want to combine. So if you're a collision tech and you have still a spot welder, and it is so kinked in that you say, well, I need speed, I'm using Bondo anyway, I'm going to spot weld a few of these things. Use it, combine it with lateral tension, just a thin line of what you're repairing, but it is possible with the system. This is on a show last year in Brussels. I had a guy jump on a door. So it's just another example of many. Some guys say, we don't like it that you do that, just pop the thing. Well, I understand that if you put a lot of pressure at once, it kind of makes a popping sound. But there's one advantage of it. If you create the right metal flow, there is nothing against it that metal releases as far and as correct as you want. It's the best situation to be in. Because if you have the door right here now, leave some tension on it, and just start fixing the rest of the details. There is nothing against it releasing it to where you want it to be. But again, as you can see here, above the body line, under the body line, above the body line, tension running through the strongest bit there will help you out. This is a repair from Barry here. You have to look at the side here, completely kicked in. What happens with the right lateral tension? You see, he kept it smaller, closer together, but took advantage of the metal under the brace. The mini foot in there and started repairing. So look at that dent and how it behaves. Only lateral tension, no help of nothing else. So it's releasing almost back to original. Just give it some pushes. Make sure you build up the area that needs to stick up, accepting that brace. Will you see what lateral tension did here?
Is it
What
bent
better?
at the edge of the door there, or was that bent before?
That was bent. It was, yeah.
It's the beginning of the repair, of course. I don't have the finished video of this.
No, it's our electric, we had a big storm in Ireland, and that electric went out for a week. It's only back on. But I would say the feet, there's a bias in the feet. So you're, sorry John, a foot has bias. What I mean by that is there's one side that pushes and one side that pulls. So a lot of guys are having problems with diving. You'll only get dive when you're coming up high push. So a tab has a leading edge and a trailing edge. So if I have, sorry John, go over here.
I only have 2 minutes, Barry.
So you put the tab there and you're pushing this way. You have a bias, and your bias is push and pull. You get more result from a pull than you will from push. So put the tab here. The leading edge is always the push. So if you get your bias on put there, the leading edge will tip in. So you'll have a leading dive and a trailing high. So get it over here. When your panel, metal, that sheet of metal is not elastic. Anybody thinks their panel is elastic, it's wrong. It's only a spring. And your spring tension, if you have your panel and your panel has went in, your door gap here, your gap to the fender here, this may have come in by 1 millimeter and 1 millimeter. That's 2 millimeters of drop in your panel. Your 2 millimeters of drop, when you do that and that and that, you'll probably see about 3 millimeters, 6 millimeters of drop in your panel. So if you can, that panel will drop of 3 millimeters by 6 millimeters here, it'll come up and maybe settle at a 2 millimeter depth. If you push on there and push on here gently, you may have an apex on the top of your panel. That apex will flow if you put marginal pressure. A marginal pressure, put the pressure on first before you start cutting braces or anything, so that will pull that up. Your peak will start to come down. If you pull too much pressure too quick, you will invert that peak, and that peak will do that. That peak now in metalwork terms is called a tuck. That's a peak, that's a tuck. A tuck is a shrinking tuck. You've shrunk the metal, it's locked up. A tack tip that I use, if you have that up, small amount of pressure, heat the brace, this brace is a bimetal bond. If you can get that bimetal bond to start moving in, you will release pressure. The the apex will come down. Take a piece of Gorilla Tape, put the Gorilla Tape onto the peak on there, make a handle the same way the guys pull their taillights. Put it on, and as you're pulling to the marginal pressure, do that, and that peak will flow down into where you want it. If you get that right, that's grooving. If you don't, you go with heavier stuff. Your panels here, your panels down.
I think for the rest, I need to come to our training.
Oh, sure. Where this comes up, the panel's not elastic. So it comes up, use of heat. The first place I would do on the door skin isn't here, down here, where this chassis of the doors, John's talks about. This, your door skin left down there. This went down. Crystal, you were saying word for this pulled this in, so that spring tension, not elastic tension, came in on the bottom edge of the door and out. Take a 2-pound hammer, a block of wood, get about all up here, go in there and go on that edge, and that will take that edge from in here out, and that takes your panels out. That's a great help. Start and save your panels. Sorry, John.
No worries, thank you, buddy. There's going to be some trainings in Europe pretty soon that we're going to dive deep into the details of all the lateral tension. The thing is, very important, what he touched here was lateral tension, guys. If you remember one thing, you want to pull as much as you can, pull on the panels. Because if you're pushing, the risk of creating more damage than there already is greater. And then you're pushing on the edge of panels. If you can pull them, it's a way better repair. And as to stop with, I'm going to show you this. It's still with one of the prototypes, but it's an Audi aluminium repair that we did here. And you can see half of the foot will be over the door edge. So you can see that the actually tool is pulling on the important side of the repair. And the rest of the repair is holding. So this is an aluminum door, like you would say here, from an Audi A7. So pretty strong, and they thought they had to throw it away. We repaired it in 40 minutes with lateral tension. As you can see, pulling and allowing the ball feet to work and to just push those dents out. So that was it, guys, for this seminar. Thank you for being